everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. The topic of this educational session today is how exactly did we humans come to believe that we have a memory. Human memory is a tricky thing. Everyone believes that they have one, and few doubt that it is a core function of our species psychology. The evidence for its existence is undeniable. Without it, it seems you could know nothing. You also know what it means to lose one's memory. You see it in others and maybe yourself. On the other hand, the existence of memory in itself is not something you can sense directly. You cannot see or touch memory like you can see or touch a ball, for example. As with all psychological functions, you can only infer you have a memory or identify some cognitive entities as constituting memories. This raises the curious question of how exactly you came to believe that your memory exists. The question is not as simple as it sounds. It is surprisingly difficult to decide which of your cognitive experiences is or is not a memory. You have no direct indicator or label for memory like you do for example, say the color red. And the term itself is ambiguous. If memory is defined as any persistent change in the mind, which stays in the mind, then any thought that goes through your mind could potentially be labeled a memory. Even what we call sensory experiences or experiences of feelings are only identified as being so in retrospect through memories of them. The example, when you say that was a sensory experience of a chair, what is being designated as sensory is not the experience itself, since that has done before you choose to label it. If you later ask what was that, the reference must be to a memory of the experiences and not to the experience itself. There are many other cases where it is difficult to tell if something counts as a memory. For example, remembering thoughts, generating plans, forming opinions or beliefs, creating fantasies, concocting lies, intermediate step in a mental calculation, logical conclusions, and etc. and etc. All of these are thoughts, and all of them can be made to reappear in your mind long after you were originally present, days or even years later. So they all seem to be memories of a sort. Even the act of deciding that particular thought counts as a memory itself quantifies as forming a new memory. You could recall that decision later on. Yet these are rarely called memories, and when they are, the designation frequently depends on the frame of reference from which you approach the question. To answer the question, we should first note that our understanding of memory is heavily influenced by having a single, discrete word for it. This despite the fact, as we considered already, you have no clear singular understanding of memory underpinning the word. In practice, as you try to appropriately analyze and interpret your diverse mental experiences, all you see is a flurry of thoughts running around your mind, blending into each other. Occasionally, you may find that the term memory is proportionally and provisionally suited to a situation. I say provisionally since with further investigation you may change your mind and update the label. Perhaps it wasn't a memory after all. Yet it was not mere happenstance that made your label a thought as a memory. There must have been some reason. And thought that decision may change over time in any given moment. The reason is quite specific. So, what makes a memory stands out for you among its peers as a special type of mental event. One feature you may point to is that memory has a sense of being representative, of somehow influenced or shaped by reality. When you say that a person has a good memory, you mean that they faithfully recall events, as we all objectively agree that they happen. Any injection of preference, reinterpretation, or exogenous elaboration arguably detracts from a memory being good. The idea that memory is a form of objective representation raises another thorny issue. Can you remember your own thoughts? In practice, you clearly can. As in, I remember thinking that, for example, Tim was trying to attack me. Unfortunately, such facts cannot be confirmed by anyone else. In such cases, the rest of us may decide to provisionally accept that the speaker is able to remember his thoughts as in necessary to evaluate a particular situation. Like, for example, if he argues that he preemptively struck Tim because he thought he was under attack. In summary, it seems that people generally feel comfortable designating something as a memory to any degree that it contents represent something objectively real. And it is only a legitimate memory insofar as it mirrors the corresponding event. If the initial memory is altered over time, then the altered part ceases to be a memory and become fabrications. Though until your error is shown to you, you will continue to call your fabrication as a memory. Anytime you identify the source of your memory as being in reality, however, you are not actually referring to reality itself. When you say that your memory of sunset was a real event, you're referring one of your thoughts, the thought of the sunset, to another thought that was supposedly the time you saw the sunset in real life. I can refer the memory to reality itself since that happened years ago. The separation of memory from reality is thus an artificial split between two different sets of thoughts. The relation between the memory and its real object is something we assert after the fact. Crucially, it is not an inherent feature of the thought itself, uh, a feature that causes me to immediately recognize it as a memory. The property of being a memory is appended to the thought later as a way of establishing its representative nature. The artificial nature of the split between memories and realities is especially notable when memories are of abstract entities. The veracity of expression, like I remember you were angry, or I remember when our government was competent, is tricky to evaluate since they involve abstract interpretations, anger, government, competence, that cannot be verified except by a communal agreement. Um, like, for example, that the government was indeed competent. Memory here, rather than aligning individuals on concrete sensations like color of the ball, is being used to align subjective interpretations. This makes the definition of memory fairly broad, one which is indistinguishable from shared opinions. The only thing the other people about what that happened based on the content inside one's head. The only thing these various examples have in common is that when you designate a thought as a memory, you are asserting that it is a reflection of some real event that you and other parties agree happened. I remember that you said you were going to the store, so I didn't go myself. You may say any such judgment could always be wrong, of course, but the inherent veracity of this claim is not a causal factor in designating it a memory, as long as you wished to assert that it was correct at the time. This is why the term memory only becomes an argumentative tool. You quibble over who is more accurate. What is important is that you are establishing some thought content as a representation of something real, meaning everyone, including you, should agree to its validity and act accordingly to it. And you only need to assert that a thought is a memory to the degree that you want everyone to accept the point. The rest of your memory's contents may be grossly in error, and it wouldn't detract from the veracity of the part that was designated as true. All of this may be difficult to stomach. Until now, you probably felt you had a good grasp of what memory was. Even still, you might have a prototypical example that you deem to be solid case of memory. Like, for example, I can think of that time I went to the seaside and watched the sunset, and my detailed thoughts regarding it are certainly memory. If they were not a reflection of reality, where these images came from. And to be clear, nothing in this presentation is meant to suggest that you cannot have thoughts that reflect empirical experiences. Certainly you can, but since you never really know how much of those thoughts are an addendum of the actual event or reflects that you were thinking at the time and not what you were experiencing, your belief is something um, is that something is memory cannot come from a relationship to reality itself. Some other force compelled you to decide that it was. Um, Nor we can point to the individual memory itself as its own source truth, even when there are of external events. Human memories, unlike computer memory, are liable to evolve over time when you recall them, to the point that two people may end up with incompatible memories of the same experience. The sources of these modifications are difficult to trace, but they're certainly not aimed at increasing the veracity of their content. Your mind doesn't inherently seem to care how accurate a memory is, as evidenced by the fact that it is so easily willing to let your memories be altered over time. Rather, your mind cares about the utility of the thought, that is, it is looking for an interpretation that serves your aims. Increasing the accuracy of one's memory is usually a conscious activity and aspiration. You may, at some point in life, decide you need to study various skills, like, for example, mnemonics, to apply them when you think it is important to buttress your mind's natural retention capabilities. The fact that you must learn these skills implies that such improvement wouldn't have happened naturally without your intentional effort. Such effort also implies the presence of a driving motive, which is specific to circumstances, like, for example, school, important social encounters, examinations, and etc. Without these motives, the efforts would not have been undertaken. There are other situations where the an inaccurate memory may actually be a benefit. It is a common error to assume that having a good memory is ipso facto useful for survival. Many people throughout history have been put in social disadvantage by remembering what everyone else would prefer they forget or misremember. Indeed, if credibility is what is at stake, then memory is a reflection of objective reality, only useful if it matches your society selective construction of reality. To have a good memory is to pay attention to what others deem to be of value, to interpret and remember experiences as others deem to be correct, and to disregard all else. If we accept these arguments, then the whole notion of memory as we have come to understand it collapses. It doesn't feel as its memory anymore. if it can be arbitrarily altered based on what is useful to you. This conclusion would likely to be rejected by many as being simply ridiculous. It is hard to overcome millennia of prejudice about what the mind does, to accept what our desire to be accurate um, re- records of reality was never built in our neurology and is more a personal preference than a natural function. Some may even feel that to argue the matter is to cast unnecessarily doubts on the communal evidence of truth that we have erected. Uh, not Nor do more people even want to be asked how they know their memory is a reflection of something true. They brush it off as a philosophical navel gazing. This is more or less the case throughout the field of AI. Nearly all machine learning paradigms are actually based on the assumption that the purpose of memory is to be an accurate reflection of empirical evidence. This principle is so foundational to the field as to be bound and beyond dispute. It is a part of AI's legacy as an offshoot of data science. For example, autoencoders are designed to replicate their input data sets as closely as possible in a compressed format. Compressing the source distribution by discovering and exploiting underlying patterns is a merely convenience, however, a means to an end. In the end is always accuracy. Generator models, of which large language models and image models are a subset, are also trained to replicate their source material and are evaluated by their adherence to the original. And finally, adherence to an imagined underlying distribution of a data set. For example, the KL divergence is the gold standard of all supervised and semi-supervised machine learning. Accuracy is a goal, and in position we have placed on machine learning models, just as we have placed it on each other. An accurate memory is lauded by society as being profitable to its aims, namely progress through collaboration. It is no wonder then that we each invent our own concept of memory out of desire to build consensus between ourselves and others regarding what is real, and that we subsequently use the word as a means of enforcing that shared agreement. Memory becomes a moral junction, as in, because we value consensus, we should have always have an accurate memory. It is similar to blame, not a concrete mental function, but a subjective interpretation that is useful when enabling some purpose. The phrase "you should have a good memory" is a variation of "you should be a good person." And with this, we are ending this presentation. And I'm coming to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder of the Decentralized Web project and several other projects that I want to tell you about. But first, the Decentralized Web project built a decentralized communication advertising platform. It has its own blockchain instance, and it rewards people who come to our decentralized web platform and become users. It rewards users for inviting other people to become users on our platform with tokens, and it also rewards users with tokens for viewing advertising, which is very permissive. Like, for example, the user has to request start a viewing of advertising, then they view a screen of an ad for limited amount of time, and then they request viewing of the next advertising, and so on and so on. And for this, they're rewarded with tokens. The website and the URL of this project is decentralizedweb.org. Decentralized and web, these are two words. They're typed all together. Then there is dot and it ends with org. Once again, decentralizedweb.org. The meaning of decentralization that we put in our project, in our implementation of decentralization, is different than the meaning that blockchain technology put in decentralization. We view blockchain technology as fundamentally not suitable to drive decentralization, and as having multiple and fundamental flows to be able to drive and build decentralization solution. The meaning and implementation of decentralization that we put in our project is direct communication from user to user without going to a third party, namely a web server, which or a third party point which collects information and then it distributes back this information to users. Once again, we only do direct communication from user to user, and we do not go through a third party, being it a server or data collection point. And with this said, I'm ending talking about this project. The second project I like to tell you about is our marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With three-dimensional objects, there has to be specific software which loads and displays the 3D object, and traditionally the creators of 3D objects, they used game engines, and currently there are two very popular choices of game engines used for displaying of 3D objects. One of them is called Unity and the other one is called Unreal game engines. But from the very beginning of our project, we decided to build our own 3D software engine, and what it does, it reads the file of the 3D object, then it opens a window on a computer screen, then it displays the 3D object, and then it starts animating the 3D object in a way of moving in a random fashion around the window it opened. But in addition to these initial and basic capabilities, our 3D software engine has multiple additional capabilities. Our 3D software engine can speak, and it can speak in three different voices, namely a male voice, a female voice, or whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in normal speed fashion, or in a fast speed fashion, or in a slow speed fashion. The second and additional capability of our 3D software engine is the capability of voice recognition. If, for example, we have a 3D NFT moving in a random fashion around a window being animated, then we can issue our very first voice command to this 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional and important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really, wow. You can ask the 3D NFT, what is your name? And then the 3D NFT is going to reply with their name. You can ask the 3D NFT, who are you? And then the 3D NFT is going to reply in few sentences of who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or decentralization or the country called Russia. With this, the last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. Then you can come to our 3D NFT marketplace website, and now is the time to tell you the name and the URL of this website. It is 3dnft.decentralizedweb.org. 3D NFT is typed in the way of the number 3, followed by the letter D, followed by three other letters N, F, and T, and it is typed all together 3D NFT. Then there is dot, then there are two words, decentralized and web, typed all together. Then there is dot, and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, you can see number of links. One of these links point to links to accessories, and when you click on this link, you're going to see that we're offering special glasses, and when you click and order one pair of these glasses, you're going to see that one pair of these glasses is red and another pair of these glasses is blue cyan. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFT software engine and collection of 3D NFTs. But I like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our blockchain instance, and this blockchain instance allows us not to charge you, the user, to pay for the deployment of the smart contracts for the non-fungible tokens, and you do not pay transactions of transfer of ownership from one user to another user. With this said, I like to tell you that like in addition to um, like by having our blockchain instance, then we allow our users to pay for purchases and receive proceedings from sale in multiple crypto coins. And currently the choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and selling of 3D NFTs in crypto, we have a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. You can come to our 3D NFT marketplace. You can browse through the collection of NFTs. You can click on one that you like in particular and want to purchase, and then you're going to present it with a drop-down menu asking you to choose between 4 different crypto coins and fifth choice of paying with fiat currency. So let's say you select paying with fiat currency, then you're going to be presented with the next screen where you have to put the number of your debit or credit card, expiration date, and CVC. And when you click on the button to complete this transaction and make a payment, then your payment is going to be converted from your national fiat currency to, if different than US dollars, it is going to be converted to US dollars and deposited in our bank account. Then we are going to make a transaction and transfer of the initial ownership from our 3D NFT marketplace to you, and you become current owner of this 3D NFT. You can play with this 3D NFT for a while, and at some point you can decide to put it for sale. You decide on the price you put for sale, and let's say there is a second user who comes to our 3D NFT marketplace. They browse through the collection of 3D NFTs, and they see and like in particular that 3D NFT that you put for sale. They're going to go through the same motions for purchasing of this 3D NFT, and if they select sync with fiat currency, then they're going to put their debit or credit card, expiration date, CVC, and when they complete this transaction, there is going to be a transfer from their national fiat currency. If different than US dollars, it is going to be converted to US dollars and deposited in our bank account. Then we're going to have a transaction and transfer of ownership from you to the second user, and the second user now becomes the owner of this 3D NFT. Then we're going to do a transaction and transfer and conversion from US dollars to your national fiat currency, and deposit the payment for the sale of the 3D NFT in your bank account in your national fiat currency. With this said, I'm ending talking about this project. The third project that I like to talk about is built and it is developing charging products for electric vehicles, and we estimate that the number of these electric vehicles is going to go exponentially up, and currently the way electric vehicles are charged resembles the way internal combustion engines coming to places called gas stations. They load fuel and then they pay and then they leave. In the same way, owners of electric vehicles, they come to charging stations outfitted with limited number of chargers. They connect electric cable to the electric vehicle. They identify themselves to the charger by their debit or credit card. They request charging of their electric vehicle. They wait for a while their electric vehicle is charging, and then they pay and then they leave. But we estimate that the number of these charging stations is going to become ultimately insufficient to charge the exponential growing number of electric vehicles. So what we propose is to outfit a parking lot with residential high-rise or low-rise buildings which are outfitted with a ground floor parking lot or multiple underground floors of parking lots. And the owner of this electric vehicle, who lives in this high-rise or low-rise residential building, when they come in the evening from work, they could connect electric cable from a type of charger that we're building. Then they can request a start of charging. They could identify themselves to the charger, and then the charger is going to start charging at some point and do this charging during the evening, during the night and early morning, while the owner of this electric vehicle is at home. But in the same way, the owner of the electric vehicle could be working in a high-rise or low-rise office building, and in the same way, this high-rise office building could be outfitted with a ground floor of parking lot or multiple underground floors of parking lots. And this office building could be outfitted in the same way with the type of chargers that we're building, and the owners of these electric vehicles could be connecting this cable to their electric vehicles and request charging when they come in the morning to work. They could charge their vehicle while they're at work, during the morning, afternoon, and early evening while they're at work. With this said, I like to tell you the name and the URL of the website of this project. It is power.rstack.com. Power is the ordinary word for power, then there is dot, then there is a word which I can spell it letter by letter. It is Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel, altogether rstack. Then there is dot and it ends with com. Once again, power.rstack.com. On the main page of this website, we did put 3 different surveys, and these surveys are telling us about your needs, and one of these surveys is about hardware, the other one is about software, and the third one is about features. And by filling of these surveys, you're going to tell us about your needs so that we can build a new product or customize existing product to fit your needs. With this said, I'm ending talking about this project. The next project I like to tell you about built and released 2 artificial intelligence agents, and these artificial intelligence agents are tasked specifically with communicating between each other. Each of these AI agents is fit with their own avatar image, their own voice with which they can speak, with their own voice pitch, with their own AI model, and their own initial prompt and system request. And you, the user of this project, you could be just an observer of this interaction between one and the other AI entities. But I can give you an example of one interaction. Let's say the first AI entity is outfitted with, it has a female gender, female voice, it has specific voice pitch in this female voice, it has a specific large language model, and let's say the prompt with which it is tasked initially is to be very seductive. And let's say the second AI entity is having a male gender, a male voice, and its own voice pitch. It has a male avatar image. Yeah, it has a specific large language model to use. It also has a specific prompt which is, let's say, to be very angry. And when you, the user, after doing this initial selection, click to start this interaction, you're going to observe the female AI entity speaking and trying to seduce the male AI entity, and the male AI entity responding back to the female AI entity in a specific fashion. But after observing of this interaction going back and forth between these 2 AI entities, then you can stop this interaction, and at this point you could choose to save this interaction to for yourself to view it at a later point, and you can also have a choice to share this interaction and place the parameters of this interaction on the website of the project, so that our other users could see this interaction, and they could type the parameters of this interaction and experience similar but not exactly the same interaction, because large language models have a specific rule against repetition um, in their responding to requests. With this said, I like to tell you the name and the URL of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter I, followed by the number 2, followed by two other letters A and I. And it is typed all together AI to AI. Then there is dot, then there are two words, decentralized and web, and then there is dot and it ends with org. Once again, AI to AI dot decentralizedweb.org. With this said, I am ending talking about this project, and I like to tell you about two other projects that are still in development. One of these projects is about token counter and token controller. Token counter means that you, the user, like if you are using multiple artificial intelligence agents, and these agents are running on like either your own machine or they're running on a cloud instance which is providing you the service of these AI agents for your website. Then you are going to be curious and you want to count the exact number of artificial intelligence agents tokens that you are spending, and you are going to be willing to do this for to provide to have the count of these tokens during the day, during the week, and during the month, so that the end of the month bill which comes to you is not going to come as a huge negative surprise to which you're going to like pay you have to pay this bill in the end of the month. So what we're doing is counting the tokens and giving you like a chart in which you can see the growth of these tokens and the current number from some starting point like the beginning of the month, or like from the date, the same date in the previous month to the current day. And with this said, the second project that we're working on is automation agent, which records interaction, and after recording these interactions, it could you could label these interactions with a specific label, and then you could at some point recall this sequence of steps of interactions by stating the label, and then at some point during the last interaction you can confirm, for example, the step of payment, and achieve the specific aim, like for example buying a specific food item, or buying groceries, or buying a ticket for a concert, or buying a ticket for travel from a specific airline for a specific range of day and times. And with this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.